We open a textbook, everything seems settled and clear. Definitions are precise, diagrams are neatly labeled, and explanations flow logically from cause to effect. There's no sign of disagreement or uncertainty in the margins. This sense of stability is no accident. Textbooks are designed to reduce confusion and help students build a solid foundation of knowledge. By presenting information in a structured, simplified way, textbooks make learning approachable. However, this clarity comes at a cost. Real science is rarely so tidy. Behind the scenes, scientific knowledge is constantly evolving, with debates and revisions happening all the time. The stability we see in textbooks is a teaching tool, not a reflection of the true, dynamic nature of science. Textbooks take years to write, edit, and publish. By the time they reach classrooms, some of the research they contain may already be outdated. Meanwhile, scientific journals are publishing new discoveries constantly. Scientists are busy refining models, challenging old assumptions, and debating new interpretations in real time. The pace of discovery often outstrips the pace of curriculum updates. This means that while textbooks provide a snapshot of what's generally accepted, they can't keep up with the latest debates or breakthroughs. As a result, students might get the impression that science is more settled than it really is, simply because the process of updating textbooks can't match the speed of scientific progress. Scientific debate is often filtered out of textbooks to avoid overwhelming students. The technical arguments and ongoing disputes are condensed into clear, dominant theories. This helps make education manageable, but it also removes the visible signs of disagreement. In reality, scientific knowledge is provisional. It changes as new evidence emerges. In research papers, scientists use careful language like suggests or supports, acknowledging uncertainty. But in textbooks, these nuances are often compressed into definitive statements. This can give the impression that science is a collection of settled facts, rather than a process of ongoing inquiry and revision. Understanding this helps us appreciate that what we learn in textbooks is the best current understanding, not the final word. Textbooks tend to focus on what is known, rather than how it became known. The messy process of failed experiments, competing hypotheses, and replication struggles is often condensed into neat summaries. This can make science appear linear and inevitable, when in reality, progress is iterative and sometimes chaotic. Without seeing the process, students may misunderstand how knowledge actually develops. Consensus in science takes time, emerging after years of testing and refinement. Textbooks usually reflect areas where consensus has formed, providing stability but hiding the long journey that led there. Recognizing this helps us see that science is not just about results, but about the ongoing process of discovery. Students later encounter scientific disagreement in the media or in higher education. It can be surprising. If science seems certain in school, seeing experts disagree might look like a weakness. But in reality, debate is a sign of active refinement and progress. Understanding that textbooks are designed to simplify helps bridge this gap. They serve a valuable purpose by building foundational knowledge, but they are not the whole picture. Science is dynamic, uncertain, and always evolving. When we recognize textbooks as snapshots rather than final authorities, we open ourselves to a deeper understanding of how knowledge grows. Science is not just what's printed, it's also what's still being questioned. Textbooks are not flawed for simplifying. They are essential for building a shared base of knowledge. The real limitation is mistaking them for the full story. Science is dynamic, uncertain, and always in motion. Education introduces stability first so that understanding can grow, but it's important to remember that what we see in textbooks is just a snapshot. When we shift our perspective and see science as an ongoing process, it becomes less about memorizing conclusions and more about engaging with questions. Science is not only what's printed, it's also what's still being explored and debated. Embracing this view helps us become more thoughtful learners and participants in the scientific journey.